With the design rationale out of the way, now I'll show how to create one of these plates to put together this X drive base. So we are going to activate a structure, go to create new component, and I will call this plate A. Okay, and well, this is going to become a bit interesting. What I'm actually going to do, so something I could do is I create a sketch and I put it on one of these surfaces. But because of the nature of the holes we're going to create in this plate, it's going to be annoying to select everything to, I'll go back, I'll talk about that a bit more later, but it's going to be annoying to select certain parts of the plate later if we were to just click the sketch down on this surface here. So what I'm going to do instead is go to construct, let's go to offset plane, and you know what, just this one, offset plane. Okay, make it 0 distance because I want it to actually be on this level, and just go okay. It's interesting about planes, you can adjust the size of them, like I don't need this plane to go all the way there, so I'm just gonna drag it here. This really doesn't matter too much. I'm just showing you that you can manipulate the size of planes. Okay, this plane, technically runs infinitely. It's just how much of this yellow do you want to see? But anyways, back to it. Now I'm going to create a sketch on this plane here. Okay, and I can hide the sketch because, sorry, not the sketch. I can go to construction. I can hide the plane because I don't need it anymore. Okay, it automatically hides, and we have our plane. Okay, and now I can go to project, and I can go to project, and I'm going to create construction type projection. So there's two line types in sketches. You can either have a line with construction mode on, which creates lines that allow you to mark out measurements and that kind of thing, but it doesn't let you actually create anything with them. And with construction off, you create solid lines, which let you create shapes that you can actually extrude and turn into a plate later. These surfaces here, we don't actually want them in our outline of our plate, so we are going to make them construction type. Okay, I'm going to project all three of them like that. Okay, so they're all dotted. That means they are now a construction type line. Now, let's say I made a mistake, but as you can see, there's a lot of lines here. But if I made a mistake on like one line, like I draw this circle here, right? And then I realize, oh shoot, that's not what I want it to be. I want it to be a solid line. Well, after the fact, you can click down on the line and then click X, or click the button here to toggle solid and construction lines, right? I'm changing it to a solid line, as you can see now, and look at that. I can select this circle here because it's a solid line. So that's a big difference between construction and solid lines. So the plan is we're going to take these 3 holes here, these 4 holes here, and these 3 holes here, and create an outline around all of that to create our plate. Okay, just so you know where we're going. I'm annoyed by this, so I'm just going to quickly fix this one, though this is not the most efficient way to CAD. And I'm going to tangent it to all 3 sides like that. Okay, so now I'm going to go to create a bunch more circles. I'm clicking X to make them solid. So even though I changed this one to a solid one, that didn't change my kind of quote-unquote default when I'm creating lines. So you always want to look over here to check what your default is. So when it's not selected, that means it's a solid line. That's what we want. So I'm going to draw a circle, draw another circle, draw a bunch more circles. Now, the reason why I'm not really caring about exactly where I draw them, I'm just drawing them close to where they are, is because I'm just going to go back and tangent all of these circles. Now, honestly, there's probably some better way to do this, and someone's going to laugh about me in the YouTube comments later down the line, but, this kind of works. So what I'm doing here is I'm tangenting the circle to 3 sides of this rectangle. 2 of them are required to get the correct diameter, and the third one is required to get the correct alignment, like that. Alternative way, I guess, but it's the same number of constraints. Like another way I could do this is only do 2 of these tangent constraints for just alignment, like this, and then like use an equal constraint to make all of the circles the same diameter, but I don't know, it's the same number of constraints. And if it hasn't become apparent yet, constraints let you manipulate lines that set up, well, constraints to like how they're formed. So right now I'm using these tangent constraints to tangent all of these circles to their respective holes, because these are the holes eventually that we're going to have the screws go through when we're creating this plate. Okay, right there. All right, cool. So now we got our screw holes, and now we'll create some of the outline of this plate. We can create a circle, sharing this center, make it 0.5 inches. Okay, I'm going to create another circle here, a circle here. These two will do something a bit different, and then another circle here. And then afterward, I'm going to select all these circles, and using the equal constraint, make them all the same, have the same diameter. That's what I want in this case. Okay, so then from here, I think I will, okay, yeah, it'll be fine. All right, so now I'm going to create a bunch of lines, connect some of this together. Didn't want that. Here, 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 here. You want to be careful, like where you click down. So, like if I click down here, that's going to actually create a coincident constraint, meaning that this line's now bound to this sketch line here in the circle, and that means I won't be able to move it later with a tangent constraint to properly align it like this, as I'm showing you, right? Tangenting this together. That's what I really am going for here. So I'm just showing you, but usually it's better practice to like do all your lines first, and then go back and tangent instead of keep switching back and forth between, you know, using the tangent constraint and drawing your lines. I don't. Okay, you can also delete constraints, like if you see them. That there was a parallel constraint, which I don't really want right now. I'm gonna go here. I'm gonna actually put it on that dot. I'm gonna go here. Put it on this dot. Go here. Put it on this dot. And go here. And put it on this dot. Okay, and then some tangents. You want to make sure you do all of these, otherwise it's not going to come out right. Wait, what? Okay, so here this got screwed up somehow, where this dot was both on this line and the circle. That's not what I want. I want it just on this circle, and I want it to be at the tangent point, like that. Okay, so now it's fixed. And I will tangent this to here. Okay, so we're mostly kind of rocking. I'm going to extend these two lines till they meet each other. What the heck? Okay, that needs a bit more. And then blue means unconstrained. So that means you don't have enough constraints to actually make sure something's in the correct place. That is almost always a problem. So you want to find ways to constrain these lines properly. Which I can do so with the coincident constraint like that. Another thing is in this process, we like, you're kind of seeing it now. This is like a basic outline shape, but to make the plate, you need to send a certain type of file, DXF, I'll talk about that later, to whoever the laser cutter specialist is at this time. Right now it is Simone, and she'll cut the plate for you if you ask her nicely. And how it works is you put in a sheet of some Delrin. The thickness we use in VEX is 1 millimeter. And the laser cutter goes around and cuts all the piece out. But all of the corners have to be rounded, otherwise the laser cutter won't do a good job cutting. So right now we have some problems, right? We have a pointy point here, we have a pointy point here, pointy point here, pointy point here. So we need to round out all of these corners to make it cut properly, and also it usually makes the plate look better anyways, so I mean that's a plus. And so with that in mind, sometimes when you we're about to see this when we use this tool called the fillet to round corners like this. And let's say I want this to be a 0.5 radius because that's what like some of the other dimensions are, right? 0.5 this. Okay, it was fine there. I'm more worried about this one then. 0.5 this. So I want to make sure it's not kind of wheel. Actually, 0.25 more appropriate. Oh, this is up to taste, right? What happened here was there used to be a constraint from this line, coincident constraint to this point here. Okay, and now that we've added that fillet, it just invalidated that, right? The line no longer goes to this point, so it deleted all of that, and this makes this all not constrained again, which is a problem. And so sometimes when you don't want to do that, sometimes when you there we go. Sometimes when you fillet the corners, it removes your constraints, and you have to go back and constrain them to make it work again. Okay, so I got around a corner there. Something else is, if I select this surface, right, it's not all connected. That's because we have a solid line here, so I'm going to trim away some of the dead weight. Like, we don't need these lines here. You want to cut them away whenever you CAD plates like this. Cut away all your unnecessary lines. As you see, also cutting away lines can make some of these lines no longer constrained. Problem in and of itself. Why did it happen there? I guess the equal constraint got removed. Is it not showing the same center anymore? Yeah, okay, so that's another possible problem. Sometimes it decides to stop sharing the same center. And then, of course, these tangent constraints decided to disappear on us, so we have to fix that. Yeah, I mean, this is just how plate making goes sometimes. You make a change, it doesn't like, and then you have to go back and fix it. But okay, this corner was mostly fine. Okay, what do we have left? We have to round this corner. So I could just fillet this together, but I'm going to show you a different way to round corners, which is carry circle, and we tangent this to here, and this to here. Oh dear. Okay, that's not working, so I'm gonna go to parallel and make these two lines parallel as they should be, okay? And then I can trim away this, 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 and then I set this arc to something we want, I guess 0.5. The parallel constraint will work in this case. You just have to find constraints to make things line up the way you want them to. I mean, there's, of course, better ways to constrain things. So now tangent here disappeared. Okay, there we go. All right, and that's, yeah, that is the first plate, mostly done sketch-wise. Oh, I forgot to trim this. So I will now. Please don't delete the constraint. Okay, it's happy. Yeah. Okay. If that was a bit fast, sorry. Just rewatch the video. In summary, what I did was first I did a hole. I just like created these circle holes wherever I want there to be a hole to put a screw through, right? Then I create bigger circles around some of the more like cornier parts, like the corner parts of what's going to become this plate. Okay, then I connected those circles together. Then I trimmed away the inner arcs of the circles that were like inside the plate area. And then from there, I rounded out any corners. Out here, I rounded the corners by just using the fillet tool. And over here, I rounded this corner by creating a circle, tangenting a circle to these two lines, and trimming away everything else that was unnecessary. Okay, and then that created the plate like this. Yeah. So we're going to click Finish Sketch. I'm going to click on the surface, because everything is trimmed away, and all of these lines here are sketch lines. They are not breaking up this surface I'm trying to click on. Now, if this whole surface that we projected was not in sketch mode, then all of these lines, like this line here, that goes to here, that goes to here, that goes to here, right, would be solid, and that would actually break up this plate into two pieces. And maybe that sounds fine, but then just remember that that would mean, so would this box here also be solid. And we have to select like this little corner here, 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 here. It'd just be very annoying. So when you project surfaces, unless you want those lines to be solid, you probably want to put them in sketch mode. Just an important thing to keep in mind. So I'm stressing that. Okay, but yeah, because we did everything properly, this is a nice, easy surface to just click on in one swoop. And I'm going to click E to pull up the extrude function. Alternative ways to find it is you could go to Create, Extrude. If you ever just don't know what the shortcut is or like where to find any command in like the toolbar, you can click S, which pulls up design shortcuts. I can find extrude. You always want the blue extrude. Don't click the orange one. I don't know why the orange one exists. And then we can go here. Okay, since we've already created this plate A component, we want to actually create a new body. We don't want to create a component. A lot of times if you're doing FRC CADing, the teacher will tell you to CAD select new component, because you're creating a component, yeah, but in this case we're creating a new body because the component's already been created. Okay, and I might have said this earlier, laser cutting in VEX, we use 1 millimeter thick Delrin plates. So I will make that 1 millimeter thick. Okay. And so now it is a body under this component, like that.
The day after I originally recorded that,
I realized I made a slight mistake with this plate drawing, but this actually gives me an opportunity to demonstrate something about sketches and extrudes and all of that. If you see here, this is not quite aligned with that line, and actually this whole plate is not parallel to this line, which annoys me. It's going at an angle. And instead of redoing literally all of that, you can just go edit the sketch. Let's get over to it and fix some of the constraints to make things line up properly again. So I don't want that. I'm going to show a new constraint. I find this one quite useful. It's called the collinear constraint. Makes two lines linear. Okay, so we fix that. And this one here, I don't know which of these coincidences is the problem. So I'll have to delete both of them. What is this point? Oh, okay. So that's just the projection. So I can coincident this back there. Okay, and I'll do something similar over here. Yeah. Okay, and I want these two to be parallel, so I'm going to use the parallel constraint. This and that. Okay, and so all of this is now lined up properly. And we can see, yep, now it looks nicer. It's, flushed on this side. It's parallel to the surface on this side.
this works because of the timeline at the bottom of the screen, which I'll talk about more in a different video. But in essence, you're kind of going back in time fixing the sketch before the extrude, and then it updates the extrude based off of your changes to the sketch.
So now I'll show you how to create a DXF of your plate. Usually because in your sketch you have like all these construction lines and maybe extra not needed lines in your plate sketch, you want to not use this original sketch, but instead activate your plate, go to create sketch, just click on the top surface of your plate like that, click finish sketch. Okay, which will now just give you this surface simply as it is. Okay, and you can hide the sketch, and then you can right click on it and click save as DXF. Okay, and I don't know, call this plate A, 1 mm x1. Well, actually, how many of these would we need? In this design, there's going to be 4 of them, so I do x4. Okay, save that file, and then find it on my desktop. Oh, where did it go? Where do they save these to? Downloads. Okay. Okay. So we go to downloads and find that, right? And then you would go find, type Simone an email and just be like, please, user cut, say nice things, dear Miss Simone, blah, blah, blah. And then, she'll eventually get to it, but if you urgently need a plate cut, then you should really go down to the makerspace, say hi to her, and say that, oh, I sent you an email with a plate I'd like you to cut, please. Thank you. Right? And then it'll get done. You can pick it up usually like 15 minutes to half an hour after it starts getting cut. And then you have these plates to add onto your robot and actually use. So yeah.